Scientists just made major discoveries in Utah, and they're changing what we thought we knew about dinosaurs, ancient life, and even the Earth itself. In 2026, researchers uncovered new dinosaur fossils, massive trackways, evidence of ancient superlakes, and signs of powerful geological forces still shaping the region today. And it's not just about the distant past, because these discoveries are revealing something bigger. Utah isn't just a place where history is preserved. It's a place where Earth's history is still being uncovered and still being rewritten. From predator-filled ecosystems to ancient human settlements, from volcanic ash layers to entire lost environments, every new find is connecting pieces of a much larger story. So what exactly have scientists found? And why are these discoveries so important? Because the deeper we dig into Utah's past, the more it changes what we thought we knew about life on Earth. Dinosaur empires revealed, new fossils and ecosystems of the Cedar Mountain Formation. Beneath Utah's sprawling Badlands, a silent drama played out long before the shadow of humanity touched these rocks. A drama that, in 2026, is being revived bone by bone, feather by feather. The Cedar Mountain Formation, etched deep into the land, once again focuses attention on the early Cretaceous, that pivotal era when the world teemed with change. Each field season brings an abundance of new evidence, freshly exposed vertebrae jutting from iron soil, the sun bleaching hollow eggshells until they gleam. Key among these recent finds are remains linked to species like Utah raptor, the formidable predator whose sickle claws and sharp intelligence have sparked fascination for decades. Yet the latest discoveries offer a broader picture, not just about solitary giants, but about the complex environments in which they lived and evolved. The year began with the unearthing of a complete hadrosaur tail vertebra, its chevron still pronounced, a compelling testament to large herbivores that once wandered high plain swamps and floodplains. In the Musuntuchit member, paleontologists uncovered a significant cache, a new assemblage of fossil eggshells. Among these were fragile fragments attributable to at least 3 feathered, bird-like dinosaurs. The curves and surface textures offer subtle clues to ancient nesting behaviors and the presence of broods within Cretaceous undergrowth. But these fragments are more than curiosities. The arrangement and preservation of the eggshells, along with the mineral content, allow paleontologists to reconstruct local scenes. Carnivores such as Utah raptor hunting along marsh margins, and Falcarius utahensis, a transitional dinosaur species walking the evolutionary line between predation and herbivory. Falcarius's teeth and jaw remains show evidence of a dietary shift documented in paleontological literature as the species adapted from meat to leaves. The Cedar Mountain Formation stands out not just as a fossil storehouse, but as a dynamic record of climatic upheaval and ecosystem change. Close examination of the fine-grained sediments within the egg beds points to episodes of flooding that may have sometimes swept through nesting sites, influencing reproductive success for resident dinosaurs. Preservation of ancient flora, such as horsetails, club mosses, and early flowering plants, angiosperms, as well as fossil pollen, provides a richer context for understanding these evolving communities. Even fossil insects and snail shells, sometimes found adjacent to dinosaur remains, suggest these ancient wetlands were vibrant with life and subject to seasonal change. Dynamic habitats where predator and prey negotiated ever-shifting environmental pressures. Research over the past decade has begun to revise previously held assumptions. Dinosaurs from Utah's Cretaceous were not isolated or static. Instead, they were part of churning, interconnected wetlands, subject to frequent disruption and change. New evidence supports the view that these prehistoric animals adapted in varied ways to fluctuating climate, rising and falling sea levels, and changing plant communities. How did populations adjust as forests rose and receded, as wetter eras yielded to drier ones? Did feathered oviraptorosaurs, well known for their eggs and presumed parental care, truly thrive by banding together in communal nesting grounds? Or did they face increasing challenges as ecological conditions shifted? Fossilized clues embedded within the Cedar Mountain Formation continue to push understanding forward, hinting at complex interactions still not fully deciphered. Utah's dinosaur record, enriched by these finds, transforms our image of the Cretaceous, from a static tableau of monsters to a living, breathing world of shifting alliances and evolutionary novelties. Tracks, trails, and the mystery of dinosaur highways. Utah's rugged heartland is carpeted not just with the bones of vanished giants, but with something even more ephemeral: the imprints of lives in motion, pressed eons ago into muddy floodplains now turned to stone. The dinosaur highways uncovered in 2026 are routes traced in fossilized trackways, physical records of dinosaur movement, migration, and interaction across primordial landscapes. This year, researchers have returned to the vast bone beds and track sites near the Green River and the San Rafael Swell, this time equipped with 21st century technology. Portable LiDAR, drone-mounted sensors, and high-resolution imaging tools have replaced older methods, allowing for the mapping of thousands of fossilized tracks in 3 dimensions. Each subtle groove and pressure line is recovered with new fidelity, revealing not only the presence of dinosaurs, but the ways they traveled and interacted. These trackways begin to reveal patterns, parallel channels of ornithopod footprints stretching for hundreds of meters, with stride intervals that subtly shift along the route. Deep impressions, larger, broader, and more eroded, record the passage of possible sauropod matriarchs, followed by clusters of smaller prints, hinting at the presence of juveniles or herd members. Fossilized mudflats show evidence of herding, with multiple animals moving together, perhaps in response to the seasonal abundance of wetlands or the spectre of predation by theropods such as Utah raptor. In some places, trackways show sudden interruptions. Straight lines widen or become ragged where predator tracks intersect, suggesting panic or a possible chase. Machine learning algorithms trained on track shape and spacing are pushing the interpretation further, allowing researchers to hypothesize about migration and seasonal congregation, patterns seen today among large herd animals like wildebeest. Mass bone beds, once seen mainly as the detritus of ancient disasters, are now examined through sedimentology and isotopic chemistry to untangle whether these were the results of catastrophic die-offs from drought or flooding, phenomena familiar to ecologists studying modern herds.
Certain trackways yield subtle behavioral traces, overlapping footsteps suggesting social gatherings, abrupt changes in direction that might indicate flight or avoidance, and narrow side trails that could be evidence of smaller, possibly juvenile animals seeking cover. These details enrich our appreciation of prehistoric life, the drama of Cretaceous floodplains played out in every preserved stride, every fossilized stampede. Do the shifting corridors documented by these tracks hint at complex group dynamics or coordinated migration? Are they remnants of ephemeral communities, each bound by environmental constraint and opportunity, echoing across ages to meet the present in stone? Tectonic tapestries, Utah's geology, volcanoes, and the saga of the uplifted West. Utah's stones are not silent. They tell a tale of upheaval, transformation, and relentless geologic motion. In 2026, geologists have turned new attention to the mighty Colorado Plateau, the centerpiece of Utah's dramatic landscape, from the soaring spires of Bryce to the emerald arches of Zion. For much of the 20th century,
The uplift of the Colorado Plateau was believed to be the product of a single cataclysmic event. But current research, using seismic imaging and state-of-the-art geochemical tracing, tells a more nuanced story. The plateau rose not in haste, but in stages, each marked by unique pulses of tectonic energy from far below the Earth's crust. Geologists have traced these stages in uplift by reading the hidden structures of the region, bends and faults within the rock, mineral-filled fractures, and the sequence of sedimentary layers. These features reveal that the plateau has been shaped by repeated cycles of rising, falling, and warping, shaped both by deep mantle dynamics and by the lateral forces of moving continents. Volcanism, too, has played an essential part. Recent fieldwork and chemical analyses reveal ancient episodes of volcanic activity once concealed within the rock record. Layers of volcanic ash, threaded between dinosaur-bearing sediments of the Cedar Mountain Formation and exposed in other key strata, can now be dated and geochemically fingerprinted with remarkable precision. These ash beds allow for timelines of evolutionary events, each eruption marking a moment when ecological and geological transformation were closely entangled. Several widespread, fine-grained ash deposits discovered in the Cedar Mountain Formation, as well as in older and younger layers, are providing new insights into how these explosive events shaped habitats and influenced dinosaur migration routes. The stratigraphy forms a rhythmic record, with beds of lava, mantles of ash, and sedimentary layers stacked in sequence. A dynamic geologic tapestry that reflects the confluence of fire, water, and time. Maps of ancient magmatic features, constructed using magnetic and gravity surveys, have revealed relic chambers and dikes, evidence of deep-time volcanic plumbing, now fossilized beneath the plateaus. Modern geothermal springs serve as subtle reminders that Utah's underlying mantle remains restless, even today. As scientists walk these landscapes, rimmed by laccoliths, worn by water and wind, they trace with each step the story of a region forged by a partnership of Earth's deepest forces. With every fossil ashfall, with every tilt of the plateau, the grandeur of Utah's geological past is brought into sharper focus. A story not of stasis, but of continual reinvention. Granaries, networks, and the reawakening of Utah's ancient peoples. Utah's past is not written solely in bones or lava. It is also the domain of humans who adapted and thrived in these challenging landscapes. Recent discoveries in 2026 have deepened our understanding of the Fremont culture, whose settlements once dotted river valleys and canyon walls throughout Utah. Long viewed as isolated or enigmatic, the Fremont people are now revealed by new research as sophisticated, interconnected, and resilient. Archaeologists excavating storage pits and granary sites along the Green and San Rafael rivers have uncovered more than ancient corn and bean residues. They have found clues to complex planning and community organization. Granaries built with carefully selected stone, sealed with clay, and often positioned near water sources. These granaries were central nodes in social and economic life, places not only for storing food, but for gathering, distributing resources, and perhaps conducting rituals surrounding harvest and survival. Variations in construction materials, and spatial arrangement across different canyon systems point to both regional diversity and the sharing of techniques and traditions across the wider Fremont world. Charred plant remains and bones within these features reveal a varied diet: corn, wild seeds, small animals, and evidence of seasonally available resources. Close study of settlement patterns suggests coordinated labor and possibly communal activities surrounding both cultivation and food security. The archaeological record points to collective resilience in a land marked by drought and unpredictability. Evidence of long-distance connections further enriches the Fremont picture. Artifacts uncovered at sites include obsidian sourced from distant volcanic regions, marine shells likely traded from the Pacific, and turquoise beads with geochemical signatures pointing to far-off mines. These finds, confirmed by compositional analysis, debunk the myth of Fremont isolation, demonstrating exchange networks reaching far into the American Southwest. The realm of symbolism and communication is also under intense study. Utah's canyon rock art, previously mute to all but the most patient observers, is being reinterpreted with digital imaging technologies. Enhanced scans reveal faint petroglyphs, figures and motifs nearly erased by time. Iconic anthropomorphs, spiral shapes, and animal forms may denote calendars, territory markers, or narratives of ritual and myth. Some studies suggest that these panels, previously regarded as decorative, might serve as records of seasonal migration, resource zones, or even astronomical events like solstices and eclipses that structured social life. In collaboration with descendant communities, archaeologists are beginning to piece together oral traditions with the hard evidence of the archaeological record, showcasing a people whose communication systems were as complex and adaptive as the environment they inhabited. Could these rock walls be Utah's earliest archives, weaving together stories, warnings, and wisdom across the generations? How many meanings have yet to be restored to view by modern techniques and the memories of those who still call this land home? Superlakes and floods, the lost waters of Bonneville. When midsummer burns westward, the evidence of a lost inland ocean emerges under Utah's sun. The story of Lake Bonneville, an Ice Age giant whose waters once filled the valleys of the Great Basin. Scientists in 2026 are piecing together its expansive legacy, one of transformation, abundance, and catastrophe. Lake Bonneville's sheer scale is hard to grasp. At its peak, more than 20,000 square miles lay submerged, swallowing land now desert and supporting climates unrecognizable today. Cool, wet weather prevailed, sustaining marshes, willows, and vast flocks of waterfowl. With its eventual collapse, Bonneville left behind one of the greatest freshwater floods in geologic history, a surge that carved new canyons in Idaho and sent ecological shockwaves across the West. Sediment cores bored from the bed of the vanished lake tell the story in fine layers, annual bands marked in pollen, microfossils, and volcanic ash particles. These records allow scientists to date the Bonneville flood almost to the year, tying it to the rise and collapse of ancient ice sheets and tectonic stress along fault systems. As analysis grows ever more precise, the interplay of climate, geology, and regional ecology becomes clearer. Ongoing study links the fluctuating stands of Lake Bonneville to cycles of glacial advance and retreat, methane pulses, and broader global climate mechanisms. Shoreline terraces, beach gravels, and marsh deposits all bear witness to past ecologies, now long submerged or dried to salt. Archaeologists are locating ancient campsites near these old shorelines, sites that once sat by lapping water, where early humans harvested reeds, hunted birds, and watched shifting horizons of storm and calm. The overlap of environmental and archaeological records breathes new life into the region's story, showing how both humans and habitats transformed as waters waxed and waned. Patterns from Bonneville's life and death echo beyond geology, providing insights for contemporary questions around drought and water management in the arid West. The story of fluctuating lakes, sudden floods, and human adaptation resonates as both a warning and a guide for the future. Lessons from the deep past, of abundance, collapse, resilience,
and ingenuity reverberate today as the region contends with fresh challenges. Chronicles in Stone: Utah's role as Earth's time machine. With each discovery, whether a hadrosaur vertebra, a shimmering layer of volcanic ash, or a faded petroglyph, Utah further claims its title as Earth's time machine. The geology of the state compresses a chronology that stretches from the ancient crystalline basement, more than 1 billion years old, to the youngest dunes and salt flats. Fossil and lava interact in rare synthesis. Volcanic ash beds that ribbon through the rock not only record moments of cataclysm, but enable precise geochemical dating, anchors for the timing of evolutionary and environmental change. Each eruption becomes a bookmark in dinosaur history. Each flow of lava documents a pulse in the land's formation. Researchers in 2026, refining geochemical techniques and leveraging new technologies, now reconstruct the sequence of life, flood, and fire with an accuracy never before possible. Dating methods allow the matching of ashfalls with evolutionary events, migrations, and the bounds of ancient ecosystems, illuminating the tempo of change in vivid new colors. This synthesis, integrating bone and mineral, human artifact, and geologic upheaval, is turning Utah's landscape into more than an archive, a dynamic engine where Earth and life intersect in a continuous story of adaptation and transformation. As AI, LiDAR, isotope analysis, and 3D modeling sweep once inaccessible outcrops, each tool unveils fresh pages in Utah's geological and paleontological diary. With every fossil unearthed and every human story recovered from rock or soil, the sense grows. This place is not only a museum, but a living laboratory, ready to inform the science of tomorrow. From the bones of behemoths to ancient murmurs, Utah's living legacy. As 2026 progresses, Utah emerges as something more than backdrop. It is a crucible of deep time, roiling, restless, and ever resistant to final summary. This land was molded by bones rising from mud and volcanoes smearing the sky, lakes vanishing and returning as ghosts in salt and sand. Here, the tireless efforts of researchers and the voices of local communities come together, ensuring that new chapters are always in the making. The questions grow richer and the stories deeper. What will the next season of fieldwork reveal? A missing piece of eggshell? A migration corridor traced anew? An ancient icon brought back to light? How do the tectonic surges beneath the Colorado Plateau and the shrouded histories of once mighty lakes continue to shape the present? In Utah, every layer peels away another mask. A vertebra from the Hell Creek mud, a bead buried in a Fremont house, a barely there glyph illuminated by a scanner. Each might yet rewrite our entire narrative. Is Utah finished revealing secrets? Or do its rocks still hold, compressed deep below the surface, the next seismic surprise for our restless search? The land listens. Perhaps as we walk it, the pulse of deep time travels upward, from the ancient bedrock through our boots to our hearts, inviting us to bear witness to mysteries still waiting to be known. Utah's stories, ancient and living, remind us that beneath our feet, deep time is always present, always unfolding, always alive.